Okay, so we have a grating here, and we shine a beam of white light through it, which consists of a spectrum of light all the way from violet to red. So of course the bright fringes will be formed at angles as according to this formula, d sine theta is equals to n lambda. We know that violet light has much shorter wavelength than red light. So for the same order, the bright fringe for violet will be formed at smaller theta compared to red light. That's why the first order spectrum will always start with violet light, then it goes through the entire rainbow spectrum, and it will end at the first order red bright fringe. So basically this we can call the first order spectrum. Alright? And of course the next order will be formed at higher angle, but it will always start from violet first because it has the shortest wavelength, so it's formed at smaller theta, and it will go through the entire rainbow spectrum and it will end at red. So this is the second order bright rainbow spectrum. Okay, so all looks fine until we bring in the third order spectrum. In this question, we have already calculated that the second order red will be formed at an angle of 40.5 degrees. This angle of course refers to this angle here. And we have also calculated that the third order violet is formed at 31.7 degrees. So you see the problem now? Because the third order bright fringe actually begins before the second order spectrum has ended. That means there's an overlap here. Basically the third order rainbow spectrum will start from here and you'll end all the way somewhere up there. But before the second order spectrum has ended, the third order spectrum has already begun. So there's overlap here. So we cannot see two distinct second order and third order spectrum, unlike the first and second, which we can differentiate because there's a gap between them. Alright, so I hope I've made it clear. That's all I want to say. Ta-ta!